Good morning, respected ma'am. I am Pujita Krishnan and I am here pursuing my second year BTech from Institute of Aeronautical Engineering, Dundigal, Hyderabad. I am pursuing my education in Electronics and Communication Department. I am here to present my art concept video presentation on the topic Parseval's Theorem for Discrete Time Signals in the subject Signals and Systems. My roll number is 21951A0477. I am from section B. Well, before getting into our presentation, I would like to thank my department for giving me this great opportunity as it helped me in gaining a subject knowledge and also get knowledge about this particular topic in signals and systems, and it also helped me in gaining experience of how to do the PowerPoint presentation more creatively. So yeah, let's get into our presentation. Signal process systems. What are signal process systems? Basically, it is about there are three types of signal process systems, which is analog system, discrete time system, and digital system. So analog system, this signal given as continuous time signal, and the output we get is continuous time signal. Whereas in discrete time signals, a discrete time signal is given as input, and output also will be given as discrete time signal. And the last one is digital system, where the input is digital system signal, where the output is also signal. So this is about signal process system. So let's get into our next slide. Is signal process systems. Let us know what is it about. Facilitate the extraction of desired information. For example, signal is given and signal processing system process it undergoes this process and gives the outputs. So it is about two types, that is filters and parameter estimations. So this is what it is. The taxonomy of signals. What is a signal? A signal is a function that conveys information. So there are two types of signal, that is continuous and discrete. Continuous is analog signals and continuous time signals, where that is the discrete one. And discrete time discrete is discrete time signals and digital systems signals. So this is about taxonomy of signals. What is the energy of a sequence? What is energy of sequence defined as? It is defined by a E equal to summation of n equal to minus infinity to plus infinity mod x of n whole square. Operations on sequences. So there are four types of operations, that is sum, product, multiplication, shift. Sum is x plus y equal to x of n plus y of n. Product is x into y equal to x of n into y of n. Multiplication operation gives alpha x equal to alpha x of n. Shift is y of n equal to x of n minus n naught. This is about operations of sequences. Sequence representation using delay unit. X of n equal to summation of k equal to minus infinity to plus infinity x of k del n minus k. And so this is about the formula, and this is the graph which represents the sequence representation using delay unit. So let's get into our main topic, that is Parseval's theorem. What is Parseval's theorem basically? It states that the total energy computed in the time, let's take the highlighter for now to mark it. Parseval's theorem states that the total energy computed in the time domain must be equal to the total energy computed in the frequency domain. It is a statement of conservation of energy. The following equation defines the continuous form of Parseval's theorem. That is integral of minus infinity to plus infinity x of t dt equal to minus infinity to plus infinity x of f square f whole square df. The following equation defines the discrete form of Parseval's theorem. that is summation of I equal to 0 to n minus 1 xi whole square equal to 1 by n, summation of k equal to 0 n minus 1 mod x suffix k whole square, where xi equal to xk is a discrete FFT pair and n is the number of elements in the sequence. So this is about Parseval's theorem. Parseval's theorem, average power of x of t is calculated from the time or frequency domain by time domain. P average equal to 1 by t, that is minus t by 2 plus t by 2 x of t mod whole square dt equal to a naught square plus half uh, summation of n equal to 1 to infinity a n square plus b n square. There, whereas the frequency domain is p average equal to summation of n equal to minus infinity to plus infinity mod c n whole square equal to c naught square plus 2 summation of n equal to 1 to infinity summation of c n whole square. Discrete time signals. So there are many types of sequences. Let us get into this elementary sequence. What is it about? Unit sample sequence. This represents del of n equal to 1, comma n equal to 0, 0, comma n is not equal to 0. So when it is 0, then it is n. When n equal to not equal to 0, then it is 0. And when n equal to 0, then it is 1. So del n minus n naught equal to 1 where n equal to n naught, and when n equal to not equal to n naught, then it is 0. This is unit sample sequence. Unit step sequence. So u of n equal to 1 when n greater than or equal to 0 and 0 when n is less than 0. U of n minus n naught equal to 1 when n is greater than or equal to n naught and 0 when n is less than n naught. That is del of n equal to u of n minus u of n minus 1. U of n equal to summation of m equal to 0 to infinity del n minus n. Rectangular sequence. N r of n equal to 1 when 0 is less than or equal to n and which is equal to less than or equal to capital N minus 1 and 0 otherwise. This is about regular sequence. Now let us know what is sinusoidal sequence. N of n equal to a cos omega naught n plus phi. Where a is amplitude, omega naught is digital angular frequency, phi is phase. In x of x1 of n equal to 1.5 into cos 0.05 into 2 pi n, and x2 of n equal to 1.5 into sine 0.05 into 2 pi n. Let us get into our next topic, which is real valued exponential sequence. This is another form of sequence where x of n equal to a power n, where a belongs to R. X of n is convergent when mod a is less than 1. X of n is divergent when mod a is greater than 1. x1 of n equals 0.001 into 1.2 power n. x2 of n equal to 0.2 into 0.8 power n. The next sequence that we get is complex valued exponential sequence, which is x of n equal to e power phi psi plus j omega naught into n, where x of n equal to e power psi n cos omega naught n plus j e pi n sine omega naught n. So where it is the attenuation factor, and x of n equal to 2e minus 1 power 1 minus 1 by 5 plus j pi by 8 into n. Thank you, ma'am, for giving me this great opportunity to present my concept video presentation. Thank you for listening patiently to my project. I hope you liked my presentation, ma'am. Hoping for a positive feedback. Thank you once again.